Okay, so I'm gonna attempt to speed run by explaining this, but I'm gonna speed run it because I won't go this fast. So if I make any like mistakes or all that, just don't blame me. I'm trying to do as fast as I can because for fun. But now let's start it. So here we have a function, right? So we multiply by two functions, so we can obviously start by integrating it by parts. So when I like to do integration by parts, I like to use a DI table. It's easier to like deduce things. So plus minus, we can make inverse tangent our derivative, right? And then we can make x to the fourth our integral. So derive that, we get 1 over 1 plus x squared, we divide it, and then this will just be 1/5 over x to the fifth. I mean 1/5 x to the fifth, right? So we draw the integral, we circle, so we can integrate that. So I will just be 1/5 x to the fifth inverse tangent, right? Minus our integral, and so it'll be 1/5 x to the fifth over x squared plus 1. We can bring on 1/5 to the front, and we can rewrite this as one more time. 1/5, right? And now we have a problem. X to the fifth over x squared plus 1, right? So we know that the power up here is bigger than the power on the bottom. So what we can do is that we can do partial fraction decomposition. We can do partial fraction decomposition by using log division, which is very lucky because we don't have to do all that a, b plus c crap. So let's do it. X squared plus 1, and then box it x to the fifth on the bottom. Okay, so x, how many times can x squared go to x to the fifth? Well, this be x to the third, because obviously x squared 5 minus 3 is just 2. That's how exponents work. So we can break it down, we can subtract. So 1 times that would just be plus x to the third, right? So that brings, so minus plus would just make it, negative, so x to the third, right? There it is. So that will go into here one time, right? Because 3, negative 3 minus 2 will just be negative 1, right? So we can bring that, we can bring it down, so that'll just be negative x to the third. Obviously we're doing this, so then 1 plus that will just be negative x, right? So we can just close it. That will just cancel, so negative will just be positive, right? So this will be our remainder. That's our remainder function, right? So obviously we can just write that as x over the x squared plus 1, and now we have it way more easier to work with, right? So we're gonna go here, right? So this would just be, when you integrate that, that would just be 1 over 4 x to the fourth. When you integrate that, that would just be negative 1/2, and then negative 1/2 x squared, right? And now we have to deal with that. That's pretty easy because that's just very simple, like u sub, right? I'm gonna come over here so it's easier. So here we have the integral, right? This is very bad, but I don't care, right? So we have that integral. So we can make u equal x squared plus 1. And then our du will just be 2x dx, and then we can always just divide, so dx equals du over 2x. X cancels, there's a 1 on the bottom, so it'll be 1/2 integrated 1 over u du. We can just bring the 1/2 down. Oops, we can bring the 1/2 down, right? There, that'll just be natural log, right? And then negative and positive numbers, it will still be positive, so we don't need that absolute value sign. So we just bring down, we just use close parentheses, and then there we go. Now we have our answers. So now all I have to do here is to combine it, and combining is pretty easy, just basic arithmetic. So 1/5 x with tangent, inverse tangent, right? Okay, negative 1/5 times 1/4 would just be negative 1 over 20th. We can bring down our x fourth. Negative 1/5 times negative 1/2 would just be plus 1/10. Bring down, and then negative 1/5 times 1/2 would just be negative 1/10. Bring down our function x squared plus 1, and we are done. Plus c, and circle, box it, whatever. There you go. That's the answer.